The aim for our physics project was to determine the effect of mass and height from which the rock is being dropped, which are independent variables on the velocity of a rock, which is the dependent variable.
So for our hypothesis, we basically stated that when the mass of the rocks were to be increased, it would have no effect on their velocity. This is because as long as the initial conditions that are acting upon the rocks are the same, their acceleration is going to remain the same, which is 9.8 meters per second square. And if the acceleration is the same, then the overall velocity would also be the same. However, we stated that when the height of the rock from which the rock is being dropped were to be increased, then the overall velocity of the rock should also increase. This is because an increase in height is proportional to an increase in time, which means that the object would be accelerating for a longer time if the height was higher, and this means that their overall velocity would be higher.
For our method, we divided into two parts. First part is manipulating the mass of the rock. So we measured the mass of each rock using a top loading balance. And using a meter stick, we measured the height, which is 250 centimeters or 2.5 meters, which is controlled. And as the rock was dropped, we recorded the time using a slow motion application, and we did this 5 times. For the second part, which is manipulating the height, we measured 5 different heights using the meter stick, and we use the heaviest rock as our controlled variable, and we recorded the time using the slow motion applications 5 times.
Okay, so what we found was that when we increased the mass of the rocks, there was an overall decrease in the time it took for it to reach the ground, which corresponded with an overall increase in the velocity. There was a linear trend that was found. However, it is important to note that the graph wasn't as steep, indicating only a slight increase in the velocity. For the second part, when we increased the height from which the object was being dropped, the time taken also increased. This corresponded with an overall increase in velocity. However, for this part of the experiment, the graph was much steeper, indicating a higher increase in velocity. So in conclusion, what we found was when the height of the object was increased, from which the rock was being dropped was increased, then the overall velocity also increased. This matched the original hypothesis that we had stated. However, when the mass was increased, the velocity again increased. This did not match the hypothesis. This is because we didn't take into account the gravitational pull. So rocks that are of a higher mass had a higher gravitational pull being exerted on them, and thus they reached the ground faster and the velocity also increased. Now the limitations and errors that we found were several in our project. First of all, if we take a look at human errors, there were errors in the human reaction time for stopping the slow motion application, which changed the time that was recorded. Then the angle from which the rocks released were also different, not necessarily controlled. Then there were limitations in our method. We weren't able to control the surface area of the rocks as their mass increased, their surface area increased, and the drag increased, thus affecting the data. And then there were 2 systematic errors that we looked at. First of all, probably the top loading balance was not calibrated properly, also affecting the data, and also there were there were uncertainties in the instruments that we used to measure our data.